Alright, hi, I'm so sorry this is taking so long to get around to, and I would have forgotten again if you hadn't reminded me, but here we go. So question 6, because you said to skip 4 and before it, and I have to skip 5 because I don't know how to teach this properly. Question 6, you ask how to prove that it's an asymptote and not just a jump or removable discontinuity. So a horizontal asymptote is different to a vertical one, in that a vertical asymptote is about something that the x value can't be a certain thing, right? So it's your input value that is the affecting thing. So let's say you have root x. Actually, that is a really bad example. Let's say you have 1 over x plus 3, right? You'll have a vertical asymptote at x equals -3 because you can't divide by 0. There's a specific input that you have that doesn't work. But in that same function, you'll have a horizontal asymptote at x equals 0 because you can't have an output of 0 when your numerator is 1, right? It doesn't matter what you're dividing by. If 1 is on top, 1 divided by something will never be 0. So these two things are very different because if you have your input as the thing causing an asymptote, or a discontinuity, it's essentially saying that you can't have that one specific point on the x-axis be a value, right? Because you'll have it look like this, and then one hole there, or you'll have, obviously, like with the asymptote, with the asymptote, you'll have it approach from opposite sides or something like that, right? But it's because it can't take this one specific x value, which is whatever this x value is along this line. The difference is with a horizontal asymptote, it's a y value that the function can't take. And because of that, it's not going to be one little jump, it's going to be the entire stretch of the x-axis. It means for every single x-axis, it can't take that value. So if you, I'm really bad at erasing things. If you have a horizontal asymptote, you're saying for every single x value, there's not a single one that will output this y value. And you're also saying, as you get really close to infinity or negative infinity, you will approach this x value. Now, you get some weird functions. I can't think of the specific example now, where it can go above, it can go through like this, and then come back down and start approaching it again, in which case it can take it at that point, but it still has an asymptote because as it approaches infinity, as it gets really big, it will continuously approach this value over here. So the whole idea that an asymptote is a value that can never be taken is a pretty common generalization, and for most cases it's true, but there are cases where you can cross straight through that asymptote, and it exists still because the function later approaches that number as x approaches infinity. So going off of that explanation, hopefully it makes a bit more sense. The whole idea of a horizontal asymptote is if it approaches it as x approaches infinity or negative infinity. And the whole answer for this basically goes over that. They go, well, I'm assuming they do. Hopefully, I haven't read this yet. Because the limit of x is the same as the limit of e to the x is infinity, we have that limit of x approaches infinity is infinity. Negative x, 0, we have limit of x as x times e to the x as x approaches negative infinity is 0. And the reason why this means that we have a horizontal asymptote is we're saying as x goes really far in a specific direction, so in this case, I don't know what this function actually looks like, but that's it, just look like this. As it goes really far this way, it gets closer and closer and closer and closer to this line y equals 0, but it never actually reaches it. And this is shown with the limits because we say as it approaches negative infinity, it approaches y equals 0. So the whole idea, essentially, to sum it up, is you can't have a small jump or a discontinuity if it's the output that's the issue. It's only if it's the input. You also had a small note here saying not that familiar with L'Hopital's rule. I'm not familiar with how to pronounce it, but essentially it's just saying that a limit of a function is the same as if you differentiate the top and the bottom. So in this case, they change the form. So they say x is the same as x divided by either negative x, which is true. And then they differentiate the top and the bottom. So differentiating x is 1, right? And then differentiating e to the negative x is negative e to the x. Oh, negative e to the negative x. And then they just plug in that same thing to test that. And the reason why this approach is 0 is because negative e to the negative infinity just goes to 0. As such, the line y equals 0 is a horizontal asymptote of the graph of the function. Yeah, so there you go. Hopefully that makes sense. Show that, okay, you had no notes on this. Oh, so that was your only, that's the only note that I could really go over. Sorry, hopefully that made at least a sliver of sense. I know it didn't necessarily clear things up entirely. It is a lot easier to explain on a call because then I know what explanation works for you, but you said you can't do that, so here you go.